welcome this afternoon to our discussion of Chemvue with LX Air. You'll see in the table in front of me, let me give you another shot of that we have the LX Air as a data logger. It's already open to Chemvue. We have sort of two versions of that. One is it'll come bundled with all our software that is sort of either our SparkView and Chemvue, which is what's opening right now. It'll also have spectrometry, a periodic table, and a help file so that if you have questions, you can go there. Whereas if you take the second choice where it's got Chemvue, it's a standalone data logger, it just opens up inside of the Chemvue, which we're looking at. And you can also get in-app help from the help files there, so you won't miss anything out. You can also share your data out and all those kinds of functions from within the app itself. So that's the difference between those two. That same cost. They're the same sort of interface so that you don't have to worry about saying, oh, missing out or something. But which one do I choose? What is nice in the dedicated data loggers is that, let me switch back here, that they have the capability to be set up from afar. That's one of the nice things about the LX series. We have had LX series in the past, but the LXi2 and the LX Air are actually built on the same sort of computing, the same specs. So they actually have everything inside the same, except we've taken out of all the interfacing sort of materials you may notice on the right and the LXi2 that has been built so that it can still interface with our legacy products and our Passport products that can be used. If that's where you still have some instrumentation, all the things I talk about today can be put into the LXi2 as well. But we took things out like the GPS, the camera, so that you could get into the LX Air for a smaller price. They're both cloud managed. In other words, a management system pushes out the load on them. So if you get it with Chemvue and you say, I'd like to have all of these, we can also push out the other and change those at your site. We just change it over the air through Wi-Fi and it being plugged in. There is a USB-C sort of cabling for that. Oops, wrong side. That you can plug in and power the device, but you can also then treat it if you want to use the USB cable to download from there. You can use the USB cable to hook this right to your laptop, and that would be good to be able to put together ways to get your data shared over to a computer. That's not the only one, which I'll talk about shortly. The browsers that are on there in terms of our help files are locked so that they can only go to PASCO sites. Also, we'll show one other feature of how that's helpful. That's our LX Air. So it's going to be set up for most common general experiments. As a matter of fact, let's go to an overhead view here. If you can see, I'm hooked up live. I've got a temperature sensor that's on here. This is the most general way we expected that it'd be sort of looking. I've got my water that I've been heating. I have sort of different ways to view this. There's a live read. That means I'm just using it like an instrument that has an LED on it. I can switch over to, let me go to the table view. Table view is going to show some things like if, hey, I want to start to record some temperatures, which I might, you're going to see whatever my setup is. I have the controls over sort of my timing. Right now it's every second. Nope, every half second. That's where that is. But if you touch the clock here, that you can set your experiment up to register at whatever rates you want. It is nice. I'll just do a quick stop so you can see this. If I look at the table setting, you can set up all of the instruments in one table. That's a little different than what the way SparkView is. You can have access. Sure. Yeah, let me cast the screen here. Hold on. We get it? No. There we go. So now you can see the screen. So that I can change all the settings for this, what my name of the run is, the color of that run. So we give you a lot more control in the interface here. And then I can switch over to the graph, which is where I'm going to turn it on and sort of let it run. So I have a slow rising temperature here. Let me just start this all over again. And it'll be collecting some data while we talk through. You can see the temperatures are rising as those go up. But we could get a heat curve, for instance, if we started off with some ice water and then slowly heated those so that we could take a look at the heat curve of water. And we'll let that sort of go through and run here. Let me switch over again. So you have these 4 tables that you can, sort of hook up if you want to record data and see the table. You want to record data, see the graph, or them both together. Those are basically the 4 tables that you have access to. It's also a smart setup so that whatever you link to the device will create a setup if it's needed. Most, when this first came out, were just single probes, and you just wanted to see, for instance, the pH change over time, or you might want to, for instance, see, the atmospheric pressure over time, or any of our instruments, and you want to see a time graph. And that was fine. That was what our basic sort of setup was. But as we've come up with more instruments that need specialty setups, we'll show you in the next, like the spectrometry setup or the melting point setup, that we'll continue to grow that line of interfaces so that you don't have to know how to set up those. And it's just really easy to get started in the lab. The last one is, how do you get the data out when you're done on the interface? Well, let's just show it right now because it's a good example. Let's see. If I'm running inside of the software and I want to share this, I'll let the data continue to run, but I'm just going to hit that sort of menu that's up on top. You see that there's an email file choice about 2/3 of the way down. And when I do that, I can choose, what do I want to send? Do I want to send the experiment itself? Do I want to send the data, the comma separated file? Do I want to say a view of the page, or even just a certain graph? So those can all be sent. And this will be then emailed to you. You'll get a link in your own email, which you can follow, and then that'll download. That also helps to provide some safety in terms of somebody using the lab to whatever. We just always have to think about those in school settings. You don't want students necessarily blind emailing anyone from a device that no one would know. And so in the email itself, it does say it came from an LXI, in the lab or something along those lines. You would download the data and then you could work from there. But all of those are built with mind and security in mind, so that it just gets to the students that captured the data and sent it to their email. They can download the data from home and set up their labs. If they have software in their lab computer, they can get the whole SparkView file, the whole Chemvue file. And if they just want the image so that they can put those into a lab write-up in Word or some other kind of format that they need, that can be done there. Okay. As we see, the scale is auto sort of zooming, which is the same sort of capability it had when you may have had SparkView on your laptop. Let's go back to our presentation, and that once the data is on there, you'll see that the Chemvue itself, if you hook up certain kinds of instruments, like, for instance, our drop counter. If you put our drop counter on there, it doesn't just take the pH change over time, which is the way the default would be if you're using SparkView. It says, oh, you have a drop counter, and volume and pH are usually the 2 things. So it would run it. And you may not notice that if you hook it up the first time, like, hey, I didn't have to choose the volume. But that was one of the kinds of ways that we wanted. If you're using the spectrometer, though, that has quite a different look to it. Our spectrometer here, I'll give you an example. Of course, looks like this. And when you hook that up, it's going to drop into what looks like our spectrometry interface, the way that it was, but it's rebuilt inside of Chemvue, and that newer sort of capability of the software, we can take advantage of coloring and some kinds of analysis where you can do more annotations and things like those. But that we're going to get the advantage of these newer softwares in their capability. It will run exactly like spectrometry did in the past. You'll see that the tabs are there with the sort of refreshed look. You can zoom in through the tables tools on the right-hand side of spectrometry, but that should be very similar to what you've experienced in the past if you've used our spectrometry software. If not, it should be very straightforward. If, for instance, you want to annotate this graph by putting a dot on this, and you choose that as your peak, and if you want to say, hey, how does that change? Like you were going to do a Spec 20 sort of experiment, you could label that point, use that as your analysis, and then say, hey, let's watch to see how that color goes away in some reaction and changes that substance. You'll actually be able to plot that height of that analysis wavelength over time and do kinetics. Here's an example. If you hook our melt point temperature up to there, that you'll get a heating curve control where you can say, hey, heat this thing up really close to what the melting temperature is and let it soak for a bit so that everything gets to be that temperature, and then slowly raise the temperature. And while you're here, take some photos so you can see when that melting occurs. That way, if you want to go scrub back and forth through those images to see exactly when the melting is finished, because it is, sort of complex, that melting doesn't just all happen. It sort of changes color first and squishes in volume and then it gets wet, that the student can gain confidence that they're measuring the right kinds of thing. But that's a nice way that we've sort of made the software in this newer sort of programming language to be able to accommodate whatever you're hooking up. Once you've gotten the data, again, we're letting our water sort of heat up and collect. That we'll take a look at the end of the presentation. But any of the data that you get, if you want to make multiple runs, as long as you're starting at the same point, let's say, hey, I'm going to hit the start button and then pour 2 solutions together, and maybe they're endothermic, and so they start to get cooler. And so you can follow, or in this case, exothermic, the graph that you see. And what's nice is if you do that 3 times, you can then go down to the graph properties, which is that gearbox, and actually choose things like, hey, let's put an error bars on this, or even a cross-run average where you average all 3 of those runs, and then use the standard deviation of those measurements so that they actually come out as error bars. If you're like, hey, but what if I just want to put the instrument error on there? You may think, I don't know what that error is. What's nice is we've also put a connection. Can you see that mouse over there, Barbara? Yeah, okay. So this area where my mouse is, you can click on that, and that'll go to our web page with the specifics for the specifications, and it will tell you, oh, this temperature sensor, for instance, can measure down to the 1/10. So if you go and you set it so that it's a fixed range, you'll put a 1/10 error bar right on there. But that way you'll have a source where you can know what the error is, and you can then portray it on your graph. We thought that was nice for AP, IB, college sort of chemistry. It was all one of those functions that it's an important aspect. We still have very common functions. For instance, if you see on the right-hand side of the tools that you can select an area, for instance, and fit a best fit line to those, linear fits, square fits. It's the same set of function fits that you could put onto a cooling curve, a warming curve, voltage and concentrations curves, whatever it is you're measuring. But you highlight that area and it'll put a line of best fit, which you see in the background, and then the formula for that line will show up. We do have visual statistics now that are inside of here so that you can see the first standard deviation in the darker sort of areas, and then further out you get the darkest line in the middle is the average of those measurements of that selection. So those are nice that you can control through the table of tools, the toolbars on the side, what kinds of best fits you have. You have another one that's a slope, instantaneous slope on the sides. So you've got a lot of control, a lot of ability to do some analysis. The Chemvue compatible sensors, you're saying, well, what if it's Chemvue and you're only seeing certain sensors, all of our chemistry sensors that are measuring gas, sort of gas conditions, for instance, like, hey, what's the temperature or the pressure of this reaction? If you're doing gas-based reactions, that you can measure those. A scale, a balance. We have some balances that we can interface into the software so that you can be measuring mass changes as well. We've got specific gases from oxygen, CO2. The air quality has ozone, nitrous oxide as measurements, ethanol sensor, and dissolved oxygen. We have solution sensors, so you could be following what's either the conductivity of something, the volume that's being delivered in the drop counter, the current if you're doing electrolysis or electrolytic cells. We have all of our sensors from the visible sensors, UV. We have a UV sensor, polarimeter if you're looking at just how much the angle turns in chiral solutions. And then, of course, there's some specialties like the radioactivity coming off of the substance. You put shielding in there, all those kinds of things, and some temperature melt points. Visually, that's this graph is showing you those same tools, so that it's really built to interface with what we consider, sort of strong line of chemistry sensors. So those are all going to be kind of there. You may say, well, gosh, that'd be great. I'd be able to get those. Is there some way I can get all of the materials like labs and, like say the keep information about each of those tools in one place that's organized? I'd say yes. We've just come out and say more and more colleges, high schools are using learning management systems. And so we have a solution for you to use a portal. The portal then you would subscribe to, and that would keep track of all the equipment that you've got. And you want to say, hey, let me quick read up about that. You could keep that in your list of equipments and go see the specifications. If you want to go and see where's the college labs, that you have on stock, those are stored inside of our portal, our experiment library. You may ask, well, isn't that all on your commercial website? Yes, it is. But this is nicely organized. Plus, it would allow you to, if you want to push those into a Canvas or a Blackboard or those kinds of areas into your own learning management, so the students would have it right there. All your software can be then handled through the portal, and so it's something that you can consider. Then you don't have to worry about. If you're subscribed to that each year, any of your school computers, then you can get the software for those. So that's a quick summary of the LX Air. It's a quick summary of Chemvue. You can buy the LX Air pre-installed with Chemvue. That's the bundle that we saw earlier. If you are curious about other ways, like say, hey, I don't want it that configuration, but you'd like to have it with Chemvue and SparkVue and the other softwares that are on, you certainly can. We will sell it that way. We hope that that's an appreciation. I'm going to go ahead and ask my colleague to stop the recording. I'm going to switch over. Oh, yeah. Let me bring up the data again so we can see kind of where we're at. Here we're still continuing to climb. We're up in about 40 or 50 degrees. 42, I think, is what we're seeing. And we could let that go until we got to boiling. We'd see some of those, sort of changes of temperatures as they're working their way through the heat curve. It's easy to do, like say analysis. I'll go ahead and turn this off quick so that you can see, hey, let's do, got to touch it on this screen. Make sure you know. I'll stop those and then we'll have the tools where we say, hey, let's make and find the best fit through there. I'll go over on the right side. It's interesting. I can move my mouse in one and put it onto the curve fit, and then I'll touch it on the screen so that I can put a linear fit on. And we'll see that we have in the middle the formula, that curve that's in that area. So that's a nice way. And when we're finished, like I said before, I can go up to the side of sandwich menu and say, hey, email me this file so that I can have it back home. All I need to do is just put an email address back in there. That'll send it to my home address from which I can, if it's the picture of that graph or if it's the data or if it's the whole experiment, I'll receive a link and I can download that and then produce the lab write-up from there. So that's the idea of making the device really useful in the chemistry lab. They don't have to bring the device home when they're finished. They can do all their analysis from home and their own software. So with that, I will go ahead and encourage us to go ahead and turn off the recording.